let's imagine that we have a line L and a point S, and that we're asked to find the distance between them. Well, visually, I know right away what I'm being asked to find. I'm being asked to find the straight line distance between S and L, and that would form a right angle with L, right? That straight height down. Well, because this is a line in space, or because I'm thinking about it as a line in space, I know I should be able to find a point on the line that I'll call P and a vector parallel to the line. And so I'm going to write that up here, that I want to find the distance from a point S to a line, but more specifically, the line passing through P parallel to V. Okay, so let's see. I need to find this distance D, and I think it'd be nice to think about this as a right triangle problem, right? Because I can imagine this angle between what I've drawn as vector PS and the line itself. That would let me write this for distance. D would equal, well, let's just think about this. The sine of theta would be the opposite of the hypotenuse, so sine of theta would be D over the magnitude of PS. So the distance itself should be PS times the sine of theta. Okay, well that's a nice formula. If I can measure this angle and I should be able to find the distance between 2 points, I can find this distance. But I don't want to have to find that angle, right? What if that angle was hard to measure, right? Or hard to find? Maybe there's another way to do it. So I see a formula like this, and it reminds me of the magnitude of a cross product. So I'm going to involve the only other vector I know anything about. If I divide by the magnitude of V and multiply by the magnitude of V, then these are the same equation. And now what I have is the magnitude of the cross product of PS and V divided by the magnitude of V. In this way, if I just know these 2 points, well, that means I know these 2 vectors. I can do this calculation for distance entirely with the vectors. I don't need to know the angle between them. So let's use this idea to calculate a distance between a particular line and a particular point. Find the distance between the line L, which has parametric equations, x is 1 plus t, y is 2t, and z is 3 minus t, and t can be anything it wants to be. So I'm dealing with the whole line, not just a line segment. And s is the point 1, 5, 1. So I want to find the distance between this line L and that point S. I'm not going to even worry about drawing them in any kind of meaningful perspective because I have the general idea of what's going on. Well, I want to use this formula, so I need to know the vector PS and the vector V. Fortunately, the parametric equations of my line let me write down both P and a vector parallel to that line. Because if I think about it, this is x naught, y naught, and z naught. That's a point on the line. That's my point that I'm going to call P. So 1, 0, 3. And then the vector parallel to my line, those are the coefficients in front of the t. So 1, 2, minus 1. So now I need to talk about the vector PS. After I have PS, I can find PS cross V, and then I'm just a couple magnitudes away from having the distance. All right, so the vector PS would be the vector 0, minus 5, and 2. Everything we're doing works exactly the same way if you do the subtraction backwards and find the vector SP, because we're going to talk about a magnitude in the end. But for right now, I'm just going to do it this way, and this is how I'd always approach it. So now I need to take a cross product, V cross PS. In the formula I wrote down a minute ago, I wrote PS cross V. Well, when I did this example, I decided I wanted to go v cross ps because I'll get the opposite sign and everything, right? My cross product will be going, the vector itself will be going the wrong direction, but it doesn't matter because I'm going to find a magnitude, right? So after I find the magnitude, that won't matter anymore. So I just need to find this cross product, 1, 2, minus 1, 0, minus 5, 2. And you can pause the video here and evaluate this cross product. I'll give you a second to do that, and then I'm going to write down what the answer is. All right, so we have minus 1, minus 2, and minus 5. There is my vector v cross ps. I need to know the magnitude of that vector and the magnitude of v. All right, the magnitude of v, well, that would be 1 plus 4 plus 1, or the square root of 6. And then the magnitude of the vector that I called v cross ps would be the square root of 1 plus 4 plus 25, or root 30. The distance I am looking for would be root 5. And there I have the distance between a point and a line.